Welcome, dear students. This is lecture 3 of module 4, which is the determination of BH curve. That is BH. B is magnetic flux density, H is magnetic field intensity. There are mainly two methods for finding BH curve. One is method of reversal and the second one is step-by-step method. This is the approximate figure or graph of a BH curve. Okay. And method of reversal. First one is the method of reversal. We have already studied about this experimental setup, is it? Are you remembering? Yes, this setup is mainly used for finding the magnetic flux density of a ring specimen. The same setup we are using for method of reversal. A ring shaped specimen whose dimensions are known is used for this purpose. So before doing the test, the string specimen should be demagnetized. That is, it should not have any magnetic property. After demagnetizing, the test is started by setting magnetizing current to a very low value. We are using a reversing switch here. What is the purpose of reversing switch? In order to provide the current in both directions. That is, if you are connecting the switch 1 2 and 1 dash 2 dash, then current will be flowing by 2 1 to the ring 1 dash 2 dash. If you are connecting the switch in reverse position, that is 2 1 dash 2 dash 1, then current will be flowing in this path and leaving by 1 2 dash. Okay, so you are providing current in both direction by using this reversing switch. With the galvanometer key closed, this is the ballistic galvanometer, and across we are connecting a key. I have already explained the circuit in the previous class, that is why I am not going in detail about the experimental setup. With galvanometer key closed, this key is closed, the iron specimen is brought into reproducible cyclic magnetic state. What is the purpose of reproducible cyclic magnetic state and how it is achieved? It is achieved by throwing the reversing switch S back and forth. That is, you have to suddenly throw the switch in current first position, that is 1 2 1 2 dash, again suddenly reverse the switch, that is cross position, again suddenly reverse back the switch in normal position, and in this way you have to do it for 10 or 20 times. For what is the purpose? In order to produce a reversible magnet or cyclic magnetic state. Cyclic magnetic state means the flux linkage will be changing. When the current is reversing the direction, there will be change in the flux linkage. Then only using ballistic galvanometer we can measure that change. Once the specimen attain the cyclic magnetic state, or once there will be change in the flux linkage in the specimen, then you have to open this key, and the value of flux corresponding to this H is measured by reversing the switch and noting the throw of galvanometer. So once you attain the cyclic magnetic state, there will be a change in flux linkage, and that is the purpose of ballistic galvanometer. It is used for measuring the amount of charge passing through the circuit. So from the charge, we have already studied how we are going to find the flux using charge. So are you remembering this equation? That is the flux found out by R G Q theta 1 to n. This is our previous lecture. Just go through the lecture. That is the finding the flux density of ring specimen using ballistic galvanometer. Once you get the throw of galvanometer, throw means angle of deflection, you can find the flux by the equation R G Q theta 1 by 2n. Okay. The value of flux density corresponding to H can be calculated by dividing the flux by area. Okay, once you got the flux from equation of galvanometer, then you can find the flux density. How will you find flux density? Flux by area. Okay, so you got the value of B. Then how will you find the value of H? H is determined by the current through this string specimen. So this is the ammeter where you are measuring the current. Okay, equation for H is given by H equal to Ni by L. N is number of turns, I is current through galvanometer, L is the length of ring specimen. Okay, so using these this equation, these three parameters, we can calculate the value of H, and using this equation phi by A equal to B, you can get the value of B. Using these two values, you can plot the value of initial B and H, B1 corresponding to H1. Okay, the above procedure is repeated for various values of H. How will you increase the value of H? By increasing the value of DC supply, or by changing the value of rheostat, you can able to adjust the value of current or increase the value of current, thereby increasing the field intensity. Corresponding value of B magnetic flux density is noted using ballistic galvanometer, and you can plot it using normal graph sheet. This is the BH curve using method of reversal. The next method is step-by-step method. This is the second method for finding BH curve, step-by-step method. In this, instead of potentiometers, see here we are using a potentiometer supply arrangement in method of reversal. But in step-by-step method, we are using a potential divider arrangement. Instead of a rheostat, you are using a potential divider, and certain tappings are there. So how can you adjust the current? By switching the S2 position to different tapping, different value of resistance will be connected, so current value can be adjusted. And the setup consists of the same setup is same as that of method of reversal. Ring specimen with a ballistic galvanometer parallel with a key. Then instead of the rheostat arrangement, you are using a potential divider arrangement. The magnetizing winding is supplied through a potential divider having large number of tappings. The tappings are arranged so that magnetizing force H may be increased in suitable number of steps up to desired maximum value. So initially, suppose if you are connecting this switch S2 in one position, so what will be the circuit path? Here current, switch S1 is also closed, then from battery current will be flowing through these all values of resistance from one then to the other end of the winding. So maximum resistance will be connected to the circuit, as the result current will be low. So if you are connecting then S2 to second position, the resistance decreases, so current increases. Again when S2 to third position, resistance again decreases, current increases. In this way you can calculate different values of B for different values of H. How will you calculate the B value? Corresponding value of B is noted from, or charge is noted from throw of galvanometer, and from charge you can able to find the flux. From flux you can get the magnetic field intensity by flux by area. So here is the steps for finding the BH curve using step-by-step method. This is what I have already explained. Tapping switch S2 is set on tapping 1 and switch S1 is closed. S2 on tapping 1 and S1 is closed. Current flow in the magnetizing winding, set up a magnetizing force H1. So a current will be flowing. Corresponding to current, you will be getting the value of H. H equal to Ni by L, which in turn increase the flux density in specimen from 0 to a value. So as current increases, ballistic galvanometer shows the value of charge, and you can find the flux density from this charge. Then H1 value may be calculated from the reading of ammeter. H1 means Ni by L, corresponding current is taken. The magnetizing force is then increased to some value H2 by suddenly switching S2 to tapping 2. So connect S2 to second tapping, so resistance decreases, current increases. Corresponding flux density delta B is noted. Then the flux density B2 corresponding to magnetizing force H2 is calculated. That is B2, you can calculate B2 from ballistic galvanometer. The process is repeated for other values of H up to the maximum point. That is, increase the value of current by increasing switch S2 in different position. You will be getting the BH curve. Thank you.